The adventure continues this week as we discuss baking inside of Modo. And specifically, if you take a look at what we're going to do here, we're going to take this baking architecture that we find in Modo and use that to our advantage to create this little pirate gold coin that you see in front of us. Now, specifically, we're going to bake out a whole series of normal maps, some displacement maps, maybe even some diffuse color maps to help us achieve a high resolution texture result, but that will eventually be placed on a lower resolution object. And let's jump in and let me show you specifically what we're talking about. I've gone ahead and opened up the class08 _ start Luxology project file, and I wanted to give you guys a simple little tour of what I've created for you. And here's our little gold coin, nothing too fancy. Specifically, if you look at the details of the item list, you may be getting a little bit confused as to what in the world's going on. Specifically, let's talk about this coin high. I'm going to deactivate the visibility of the other two, and this is what we're left with. Now, this is the high resolution coin object, so this is ultimately what I would like the final coin to look like, but with some additional surface detail embedded into that. In addition, if we jump over into our UV tab over here, let's check it out. And of course, let's grab our UV maps. There it is. There's a coin high. It's pretty good looking. Okay. Not too shabby, I think, and I'm generally really pleased with the result that we've come up with. Now, the idea here is that we take all of this high-resolution information and place it inside of a lower-resolution object. I want to extract that high-resolution geometry and apply it through a whole series of normal maps and maybe even a displacement map onto a lower-resolution object, and it's pretty easy to do that. First, let's continue to round out and create what will ultimately be the high-resolution design. So I added some other stuff here. If we go into this mesh hierarchy, I've added all these little rings that go around the outside. Just if we look at the combined composite here of what it looks like, yep, that's what it's going to be. Let's just jump over to the render tab. You'll get a little bit better illusion. Yeah, there we go. And I'm liking it. So a whole bunch of little ribs that run around the circumference of the circle kind of gives you that coin look. Now the next thing that we want to do in here is that we need to go in and start adding some of that surface detail to give us the result that we're after. And specifically, I want to add maybe a cool like pirate logo in the center, and then of course maybe some procedural textures that will beat up the surface a little bit more. So let's go ahead and do that. First things first, let's make sure that we have everything encapsulated in its own material group. So I've just selected those polygons, and now at the M key, we'll just call, oops, excuse me, I hit the wrong button. Hit the M key, and we'll call this one coin. Wonderful. And now we have a material group, and we can start influencing those polygons individually from the rest. Now, I've given you guys a really fun, neat pirate logo as part of your bundle of assets this week. So let's go ahead and just import that in. We'll load the image here real fast. It's the week 8 folder, and this is pirate logo PNG. And there we go. So we have a couple things in here that we need to kind of resolve. It's way too big. So the first things first, let's go to the texture locator and look at what we can do to shrink this thing down. Now, the computer's doing exactly what it should be doing. If you look at the original image itself, and let's just do that real fast. Here's the original image. It's a 1024 by 1024 texture, and the pirate logo goes to almost to the boundaries of our little image here. However, we only want it to be a small portion on the inside of that. Now, lucky for us, that's not too bad, and it's relatively easy to change, and let me show you how to do that. The first thing that we need to do is select our texture inside of our shader tree and go up over here into our properties tab. And specifically, we need to go into the texture locator section because there's a couple little additions and changes that we need to make in this area to get the result that we're after. Now, we first need to change the horizontal and vertical repeat. If we were to continue to scale this object down, and actually, let me just show you what I'm talking about. If I was to increase the horizontal and vertical wrap, let's just do them together at the same time. You can see that the texture is going to begin to scale as it goes down on the interior of our object, which is exactly what we want. We want our texture to be a little bit smaller. We don't get access to the size channels because we're using that UV map to project this image on top of it. So these are kind of nullified and turned off when we use the UV map projection type. But the horizontal and vertical wrap, all of this jazz down here, will allow us to very quickly change the size of our image on top of our model. We only want one of them, though, so we don't want it to repeat and continue to stamp this texture across the model. So that's where this horizontal and vertical repeat come in, because right now it's repeating the texture both horizontally and vertically. If we set this to reset on both horizontal and vertical, now we're only getting one stamp, which is exactly what we want. With that done, we can go back to our horizontal and vertical wrap and change these values to get the size that we're after. And I think maybe something right around there is looking pretty good. Now, as you go through this process, if you're noticing that you're getting some really wacky distortions across the skull or maybe within the sword blades, it's really important to point out that I'm using a Catmull Clark, so a Pixar subdivision surface, to get the result that I'm after. Let me show you the difference. So I've unsubdivided it. Let the tab key and check it out. With the tab key, with straight up Luxology or Modo Sub Ds, you can see that the texture is getting distorted from the subdivision surface algorithm. Clearly not what we want. Hit the tab key again, go back to the unsubdivided state. Shift tab will get us into Catmull Clark or Pixar Sub Ds, and you can see that the texture resolution, the texture quality is maintaining across the entirety of the surface. So again, another big benefit of using that Catmull Clark subdivision surface engine inside of Modo 901. So now that we have our pirate texture in there, and we're starting to build the illusion that we're after, let's go ahead and get this integrated into the scene itself. Now, clearly we don't want to use this texture as part of the diffuse color network. So I'm going to change the effect from diffuse color to displacement because I want to create a little bump out. And once my computer updates here momentarily, we shall start to see the effect, and there we go. Now, it's really super extreme, so this is where you're going to have to kind of dial it in a little bit. As a reminder, you can find all of the displacement distance inside the material that's responsible for shading all these pixels. And right now, my displacement distance is set to 20 millimeters, which is, in my opinion, maybe a little too high. So let's half it down to 10 millimeters. Force preview to update here in a second. There we go. Yeah, and now we're marching something that's closer and closer and closer to what my imagination has come up with. But in addition to having all of this lovely skull detail along the surface of my coin, I want to make it beat up. I want to make it look like it's been sitting in that treasure chest for millions, well, maybe not millions of years, but hundreds of years perhaps. I want to see little eroded little nick marks in here. So I think I'm going to recycle and reuse some of those procedural textures that we created last week to help us get the result that we're after. So let's do add layer. Enhance mode of textures. It's under noise, and I think I'm just going to choose etched. We'll leave the effect to diffuse color. That way, at the very least, we can get a nice little preview of what's going on here. And I think overall, I'm pretty pleased. I want to maybe have some of these etchings a little bit bigger. I'm using a projection type of solid, so I get to use the transform section to change the size of these. Yeah. I still want a good number of these little dark spots on it. That's pretty cool, and I'm pretty pleased with the result itself. Okay, that's a step in the right direction. So I'm also going to use this etched texture as a displacement. So let's just change its effect back to displacement. And now you're going to start to see some problems kind of jump into your scene here pretty quickly once update previews. Now, it's everything has grown. If you look very carefully, the size of my coin has been pushed out because now we're using that displacement engine to physically move the geometry on our meshes. In the previous week, I think we talked a little bit about bump maps, which is really just a rendering trick. Well, with the displacement map, we are physically moving geometry in and out, and it turns into real geo upon render. And now, unfortunately, because of that displacement distance, that pirate logo in the center of our coin has been nullified. It's kind of gone. So let me show you a quick little trick to get us back to what we want. So I like the pattern here. This is the displacement effect that I'm looking for, but I don't want to push the volume of my object outside. And let me show you how to change that. One small little note, and I apologize for not mentioning this earlier, to make it a little bit easier for you guys at home to see the quality and the results that I'm getting. I've gone into the options pull-down menu inside of preview, and I've turned off draft displacements. That will make it a little bit easier to see a closer representation of what the final displacement effect is going to look like. Okay, back over here into the shader tree, and we can make a quick change to get what we're after. With my procedural texture selected, there's two things that we need to do. First, we need to start blending this procedural texture with the layer below it, right? So let's go back into our texture layer section. The blend mode for this particular one is going to be set to screen. And once preview updates here, and I'm doing a lot of displacement. Yeah, it's changing a little bit. You can actually start to see the pirate logo fill in these holes. I got to apologize. I'm doing the screen recording and doing some rendering with some displacement maps, and my computer's getting bogged down. I apologize. But to really get the result that we want, we're going to change on our etched texture. We're going to change the background value to -100, not plus, minus, -100. There we go. All right, so now these holes are going to go deeper. Yep, now these holes have been pushed back another 10 millimeters, and I'm going to put my foreground value to 0. And we should see things start to unfold the way we want. Yes, there's the pirate logo. Everything's back to its original volume and size. Now the entire volume isn't being pushed out 10 millimeters. Only these dark spots are being pushed in, which is precisely what I want. I think you can already start to see the benefit of being able to blend these different displacement textures together. We're getting some really compelling results, especially down here in the swords and what have you. It's starting to look a little bit more integrated. But now that we have our displacement textures, this isn't going to render as efficiently that I want. And keep in mind, if you think about the application of this idea into our larger treasure chest scene, we have a unique problem as we have probably about 100 to 150 of these coins. They all can't be this heavy when it comes to render resolution, so we need to make some adjustments. This is where normal maps really kind of shine, and creating normal maps inside of Modo is really easy. A normal map allows us to capture height information a little bit more accurately than a bump map, to say. So we're going to be able to go in and ask the computer to analyze the mesh, fire off some height rays, and capture all of that normal information. So all these little displaced bumps and what have you are going to be captured in a map that we then eventually could be placed back onto our lower resolution mesh to get the result that we want. Let's go through that process. The setup is a little different, but I think once you get into it, I think you'll find that it's really not that bad. Now that we have our basic displacement system set up, let's go ahead and capture the normals, okay? We're going to capture all this height information that the Modo rendering engine is creating for us thanks to our lovely displacement maps, and it's really quite easy to do that. We're going to begin by going over into our item list and do a quick examination of all the different items that are chilling in my scene, and I think best scene is in the model tab, and here we go. So we have this mesh hierarchy, which basically are all the ribs that make up an important detail piece for my high-resolution coin, and here's the high-resolution coin mesh. And if you take a look at the coin low, let me just turn off these other two, this is ultimately what's going to sit inside the treasure chest. So I want to capture all that height information and place it inside of my coin low. Now, the main thing to really kind of point out here is that the coin low and the coin high are almost identical. They actually are an identical mesh. I duplicated my high and then stripped out a whole bunch of detail for my coin low. And when we're beginning this baking process, it's important to point out that we have to have our low resolution mesh object selected with our high resolution objects in the background. So their visibility needs to be on, because what's gonna happen here is that the computer is gonna go off, and let me turn off my grid real fast. There we go. The computer is gonna go off. It's gonna look at each one of these polygons and fire a ray from the surface of that polygon. Any geometry that it interacts with, that it intersects with, is going to be captured. So it's going to go up. The ray is going to be fired up from the surface. It's going to turn around, look back down at the surface, and anything that's captured, that's within a certain distance, is going to be calculated and included in our normal map. So we need to make sure that all of that high resolution stuff is available and on inside the background. So I have my low resolution mesh selected. I have my UV map selected down here because we're going to be creating a texture that perfectly matches the pattern of our low resolution UV. And there's our UVs. Everything's looking pretty great for our low. Let's jump back over into our render tab and begin the process. And it's really, really easy to do this. A couple things to point out when it comes to baking images inside of Modo. This is a camera operation. And if you have the render items selected up here at the top of the screen, you can go into the frames section. And down here, you're going to establish all of your your width and your height for all your baking operations. This is an important parameter to note. We're going to create a new texture here in a minute that's going to override this value, but this is where you can go in and find the height and width of all of the images that you can bake through a number of different baking menus. And let me show you the way that I'm going to work. It's really kind of neat. So first and foremost, we need to create a new texture. This is going to be the texture that we're going to bake to. So we're going to extract all this information from the geometry and place it in an image. So we'll do add layer, image map. And this time, we're going to do new image. Let's give it a good test. So let's put mine inside of my project folder here. There we go. And let's call this pirate coin, and then I'll put NRM for normal, and I'm a big fan of the PNG file format, so let's do a PNG. There we go, and hit save. Now, the first thing that you're going to see is this little pop-over saying, hey, you're creating a new image. What's the resolution? Well, let's just do 1K, and then most importantly, the format is going to be RGBA. We want to include that alpha channel in there, and we'll hit OK. All right, so we're ready to start baking, and it's really quite easy to do the baking process. Once again, just make sure that your low-resolution mesh is selected. Inside of your vertex map, your low-resolution UV map is selected, and we can begin the baking process. It's quite simple. Simply, we just need to go down over into our shader tree, right-click on our image, and then from the contextual menu, we'll choose Bake from Object to Texture, and you'll get this little popover. Now, this for you guys, this is going to have a value of 0 in here or no value in the distance. And we're going to talk about this cage here in a second. Leave the distance at 0 and just hit OK. And let's just see what we have. Now, the computer's going to fire off a whole series of rays from the surface of our geometry, and it's going to capture all of the information that it interfaces with inside of our system. And I made a mistake. Let me abort this. This is my bad. I apologize. I forgot one critical important step here. And we forgot to change the effect of our new image. It's set to diffuse color. Let's right click, and then under the surface shading section, we'll choose normal. There we go. Now we can start working with this. So once again, we'll right click, bake from object to texture. We'll leave the distance at 0 and hit the OK button, and now we are off to the races. And we are. Now, if you check it out, look at all that lovely etched detail coming from our procedural texture is being preserved inside the normal map, and we're going to be able to apply this back onto our geometry inside the scene. However, if you look critically at what is being captured here, we're not capturing everything. We're not capturing all the lovely high-resolution detail from the surface of our object. It's there. It's very faint. I can see some of the rings that I created in here, but it's not giving me the quality that I'm after. And I'm going to abort this real fast just to kind of make my life a little bit easier. We'll hit yes. We'll get back out of here. Now, what it's not doing is it's not getting the height information correctly. It's basically going out, and it's not looking back far enough onto our model. So we're going to make a small change. Let's do the whole baking procedure again. Bake from object to texture. And then this time, we have to put a distance. And this is how far the ray is going to go before it turns around and looks back down at the model. Now, this is a moving target. Depending on the size and the scale of your scene, you're going to have to figure this out. Here's a great way of working. Let's turn the grid back on. Look at my scene from the top. And each one of these grid squares, and I apologize if it's difficult to see, each one of these grid squares has a defined value associated with them, a defined size. And right now, for me on my screen, each one of those grid squares is 5 millimeters. So I think I need to shoot it out maybe, I don't know. Let's count these. Let's change the wireframe here. So 1, 2, 3, 4, 5. So let's do 50 millimeters and see what we get. This is one of those areas that you'll just kind of have to fine-tune a little bit as you go through this process. Let's do 50 millimeters. We'll hit OK. And now let's see what the computer is going to capture inside of our normal map. Yeah, check it out. Now we're getting much more detail. We're starting to get all of the rings from the high-resolution object showing up inside of the normal map. And overall, this is looking very, very good. However, the one problem that we're going to run into is that we may not be getting the depth that we're after. So let me show you one alternative. And this is an important see, look, there it is right there. I had a hunch. Those two dots are showing up black. That's a problem that's being created from the ray not going out far enough. Now, it can be kind of a moment of frustration trying to figure out how far to shoot that ray out. So I want to show you caged-based normal mapping and caged-based baking. It's a faster and, in my opinion, just a much more accurate way of creating normal maps inside of Modo, and it's really, really easy. Let's just let this kind of go through its process here. Yeah, it's almost done. It calculates pretty quickly, and this is the fantastic thing about normal maps is we're getting all that lovely displacement detail in a texture that we're eventually going to be able to map back onto my low-resolution object to get the result that we're after. I'm just going to let this finish baking here, and we'll place it on side of my coin low image just so we can see and understand the direct benefits of working with these normal maps inside of Modo. It's almost done. Here we go. And once it's done, there's one more important thing that we need to do to really preserve this image. There we go. It's finished. Here's our normal map, and it's looking okay. I think that's the best way to describe it. It's looking okay. So let's close this. Now, the next thing that we got to do, and this is a step that's easily missed, is that you want to go into your Images tab and right-click and just choose Save. That's going to permanently save all the details that we just baked out into the image and inside of its current location. Let's jump back over into our Advanced OpenGL viewport here. Yes, there it is. So it's been applied to the coin low mesh object. So we're capturing all of that lovely surface information and it's being preserved on inside of our mesh, which is looking pretty great. Now we don't have the accuracy. It's not perfect. So let me show you another alternative here. It's called cage bake normal mapping that will give us a different result. And this is kind of one of those things you have to experiment. It's very conditional. It's entirely based on the geometry you're seeing. But let's just talk about it real fast. To do some caged bake normal mapping, the first thing that we have to do is create a morph map for our object. The cage is going to be based on that morph information. And so here's what we're going to do. I'm going to go. I'm on my coin low area here, and under the lists tab, I'm going to open up my morph map. There we go, and let's do this. We're going to add a new morph map, and we'll just call this new. We'll just call this let's call this Baker. There we go, and we're going to leave it as a morph map, and we'll hit OK. Now, what we have to do after we create the morph map is physically change the model itself. And I want to make this a little bit bigger. With the polygon selected, I'm going to go over into my deformation tools, and I think I'm just going to push this out. The great thing about the push deform tool is that it's going to push the geometry based on its polygonal normal. There we go. So I've made it a little bit bigger. And the whole function behind this morph map is that the array is only going to travel the distance of the geometry in the morph map itself. So we've created, kind of an enlarged cage, if you will, of our geometry. And the array is only going to go as far as the cage, and then it's going to spin around and look back at the detail on the inside. And that's a good start. Let's just see what it looks like. Now, the cool thing about working with morph maps is that we can completely change and deform our geometry non-destructively. Notice that my morph map is selected. If I was to unselect it, you can see that the geometry goes back to its original form. So it's not permanent. It's non-destructive. Let's turn it off. And now let's go back over into our render environment. And actually, you don't need to be in your render environment to do that. You just need to go into your shader tree. I'm going to create a new normal map here, so a new image, just so we have a point of comparison. Let's create a new image. And I'll just call this Pirate Norm 2. Make it a PNG. Once again, it'll be 1024 RGBA. Things are good. And unlike last time, I'm going to remember to change the effect to normal before I start. There we go. And let's go ahead and bake this one out. So we'll right-click, bake from object to texture. But check it out. Now that we have a morph map called Baker, we can choose it from this cage list. Now this is going to completely disable this value. So this distance value in here is no longer important. Let's just triple check. Well, I should have triple checked to make sure I had my low resolution coin and its associated UV map selected before we started baking. And I don't think that I do. Let me just hit the abort key here real fast. And go back in. Oh, I didn't have any of my high resolution stuff in the background turned on. Let's just triple check our lists. Yep, that's good to go. Back into our shader tree here. We'll right click, bake from object to texture. We'll use the Baker morph map that I created a minute ago. And now let's see the result that Modo gives us. Hopefully, it will be a little bit more accurate. Yeah, I'm liking this. This is starting to look pretty great. Now that we understand the baking process, let's kick it up a notch. As you can see, I am working with my little pirate coin again, and I've applied some very simple materials, and they simulate very similarly what we talked about last week. I'm using some occlusion layers with some metal reflections, and you can see the result that I'm getting in. And one thing that I'm noticing is that it is taking a significantly long time to render, and most importantly, the increase in render time is coming from all of those occlusion rays. We're accessing the power of the global illumination engine, but unfortunately, it is taking some time to render all of this, and I really would love to be able to preserve all of this lovely color information that's coming from all those occlusion rays, but I don't want to have to commit to the cost that's associated with all these render rays, with all these rays. It's just taking a long time to render all of this stuff. I'd rather render it once. Okay, so we're going to preserve this. We're going to bake all of this color information because that's really the only thing we're getting here is just color information and a little bit of reflectivity. We're going to preserve all of this and bake it into a texture map. Now, luckily for us, we're going to follow almost an exact same process and procedure that we worked with before. However, slightly different. I have my coin low object selected. I also have my coin low UV map selected. But instead of creating a new image down here in our shader tree, check it out. There's one new way, or one additional way, that we can bake images inside the Modo rendering engine. If we go to the top of the screen where it says render, check it out. We can do, here's that bake from object to render outputs, but we're going to do bake to render outputs. Now, this is going to take the render outputs that are currently sitting inside of your shader tree and use that as the starting point for our baking engine. It's still going to follow the coloring book, if you will, that we created with the UV map for our low resolution object, and now it's going to take all of the information that this render output is creating and placing it inside of an image map, and you can already get a good understanding of how long it's taking the computer to evaluate the high quality, final quality image of the of all those occlusion rays that we created with inside of my material network. So it's taken a little bit of time, but the cool thing about this is that we're only doing it once, right? We're only committing to one single long render opposed to many long renders, which I, for one, am really quite thankful for. Now, the unfortunate thing about working inside of this structure is that we have to be very aware of the role of each one of our render outputs. Right now, I'm rendering out the final color render output. So what you see over here in the preview is what we're going to get. I've jumped ahead and let my computer render all the frames out, and I'm generally really pleased with the quality of the bakes that I'm getting from Modo. As you can see, we get both all the geometry and height information from the normal map. We pair that with a really great bake of all the diffuse color information and some of the environmental details into the object itself, and we're going to get a really compelling a really compelling set of images that will allow us to render the final result much faster. And I'm really digging the result both on the normal and on the final color output that we're getting here. Now, I encourage you to continue to explore the role of all the different render outputs inside the Modo rendering system. I didn't go into all of them. Actually, I want you guys to jump in and kind of get your hands dirty and see the effects that each one of these create. The best way to learn is to jump in and to get your hands dirty, as they say. So I encourage you to do that. Check it out. It's a lot of fun. I think you'll definitely be entertained by it, and start baking some things inside of Modo. You can create some very nice high quality results pretty quickly without a lot of huss and fuss. Let me know if you have any questions. I'm more than happy to help.